Selecting proper FPV equipment is essential because the antenna is your lifeline. How do I mean the antenna is your lifeline? What I mean by that is if you lose video signal and you're out 3/4 or a mile away from yourself, you're screwed. You have no video signal whatsoever, and your only hopes is that you have a return to home function on either your quadcopter or your fixed wing aircraft. So let's go through some of the proper antenna selections and some of your options that you have here. As you see, we have a rather large antenna to a mid-size antenna to a larger antenna. Now, this antenna operates on 1.3 frequency. This antenna operates on 2.4, and this antenna operates on 900. Now, as you see, there is quite a large spectrum in the size between these antennas. This is also a great dictation as to why people choose the 5.8 and the smaller band of antenna. This antenna is known as a crosshair antenna. It is a very direct signal antenna. What I mean by that is that the beam path that this antenna shoots out is very narrow, as to where an antenna like this, which is referred to as an omnidirectional antenna, shoots out a beam path like a big circle or a big balloon. So anywhere you fly around yourself with this antenna, you will be picking up the signal, as opposed to an antenna like this, which is the more directional antenna. You can fly in front of yourself, but as soon as you start to fly behind yourself, you're flying outside of that signal path and you're going to start losing the signal. Here's another option. These are referred to as helical antennas. This is a 5.8 10-turn helical antenna. This is a 1.3 3-turn helical antenna. Again, as you notice, there is quite a difference in the size variation of these antennas. So you may ask, why should I choose 5.8 over 1.3 or vice versa? That's a great question, and the answer is quite simple. A, how far you can get between 5.8 and 1.3, and B, something we refer to as object penetration. Now, object penetration is essentially exactly like what it sounds. So with a 5.8 antenna, if you have a wall right here, this signal is not going to be strong enough to penetrate that wall. So you're not going to receive any video signal from your transmitter into your receiver. As to where a 1.3 antenna would have the strength to receive that signal. What's the difference between 5.8 and 1.3 is essentially frequency. The frequency allows to absorb that much more signal. It's a stronger and a lower frequency, so you have the ability to get the signals into the 1.3s that you didn't have into the 5.8. So you ask, why do so many people fly off of the 5.8 antennas versus the 1.3, 2.4, or 900s? Well, that is again simple, because the size of the antenna. A 1.3 omnidirectional antenna is extremely small in comparison to a 900 band antenna. Here's the 900, here's the 1.3, here's the 2.4, and as you see, they all step down in size tremendously. So that is why so many people fly on 5.8. It's all about the size. It has absolutely nothing to do with the weight or the penetration. It's about the size of the antenna and the ease. So if you're flying a quadcopter, let's say a DJI Phantom, and you stick something like this on there, you're going to notice that this antenna is almost as big as the entire body of your quadcopter, as opposed to something like this being just a small dab on the quadcopter compared to a 900 frequency antenna. So why don't a lot of people fly on the 2.4 versus the 900 or the 5.8? Well, that's simple as well, because most controls are based off of 2.4. And in order to get away from the 2.4 interference, you have to take yourself off of that 2.4 control frequency and put yourself onto a different frequency, 72, 57, or even 433 for long range. They're all really good frequencies, and frequencies that you can use to get away from using 2.4 control and start using 2.4 for video frequency. 2.4 is a great signal. It's small, it's compact, and I know guys who have flown well over the 7-mile mark on just these two little antennas. So, let's talk about range a little bit. Range on the 5.8 antennas, you're probably going to max out at about a mile to a mile and a half, and that's with a great set of 5.8 antennas. 5.8 is not meant for range in any way, shape, or form, nor is it meant for any type of object penetration, which is why people who use long range or LRS systems use the 1.3, the 900, or another type of band, because we have more power, which will allow us to receive more of that signal from a longer range distance. So let's talk about some of the options that we have with our ground stations. As you see here, we have a cased ground station. Very simple. It's got an on-off switch. It's got a battery LED indicator. And as you see here, there's a couple of holes for the fan that cools off the system. Here we have a diversity monitor set. So you have two antennas that will plug in and power this monitor. This monitor will receive the video signal that is coming from the video transmitter. What happens is the antennas that are plugged in and connected right here catch that signal. They then come in, go to the video receiver, and they are then transmitted to this monitor right here. So let's take a look at some of the components that are involved in these systems. As you see in the back of this system here, there are many different components that operate together that make this system work within harmony. Here we have our battery receiver. This receives the battery power and then transfers it over to here. This is our video transmitter receiver. So here is the 1.2 frequency. This is the indication of the frequency in which this receiver takes. The signal comes in here into this 1.3 omnidirectional Lotus antenna by Spec UAV, comes into this receiver, out of the signal box, comes down into this diversity system. The diversity system then splits the video signal three different ways. We have one signal coming into here to the DVR. This digitally records the video signal in which we received from the FPV system. That is one component within itself. Here is the video receiver. This is another component. This is the diversity system. This is the system that allows us to have multiple video outs. So as I mentioned, we have a video out coming here. We also have a video out powering the monitor. And then we have another video out that is going to an optional FPV goggle display. And that is all of the system here encompassed. And that's essentially what you need to have your good FPV ground station. Another option for your video display would be FPV goggles. Now there are many different options to choose from when it comes to FPV goggles. You've got your low end Fat Shark teleporters. These goggles will run you at about $200. They're an extremely low end set of goggle, but they do work. So for somebody who's just starting out and getting into the FPV market, this is something that I would recommend, just because you don't have to spend so much money, and it's a good feel, and it'll let you decide whether or not this is something that you want to spend more money to invest in and further yourself within this hobby, or if you want to back out. A higher end set of goggles are these. These are known as the Fat Shark Dominator HDs. These goggles are almost $600, and there's several reasons for that. The reasons for that is because unlike other goggles like this, to where you're extremely bound by the features and the functions within this goggle right here is almost in feature and function completely upgradable. What I mean by that is you can remove this antenna, which is 1.3, open it up, remove the module, replace the module with a 5.8 module, and now you're operating from 1.3 to 5.8, just as simple as that. Boom. You hook up your 1.3 antenna, and you're good to go. Now you go from 1.3 to 5.8. Another great feature of these goggles is what's known as the head tracking port. The head tracking port is essentially exactly what it says. So if you have your goggles on and you've got a head tracking system on your FPV equipment, when you turn your head left, like this, your camera will turn left. If you push your head down, your camera will then pan down. So, along with the Fat Shark goggles, there are also several name brand goggles out there that you could choose from. But those goggles are extremely expensive and they are not meant for FPV. The Fat Shark company has specifically designed their goggles meant for FPV and FPV only. Not FPV only, they're also designed so that they can accept images from televisions and stuff along those lines. But who wants to watch a movie on their video goggles? We all want to be out flying, right? And that, my friends, is the FPV goggles, the FPV monitor, your antennas, and your ground station selection.